So I'm Robert Treat. I'm here to do a talk on Postgres 12, mostly around new features and things that you should be aware of in Postgres 12. This is the all demo edition, so it's all demos. None of this is recorded or scripted. That should be obvious at this point. And this script is actually theoretically publicly available. I don't have internet on, but if you go to gist.github.com/exzilla, Xzilla, there's probably like 4 gists in there, and the one that is Postgres 12 demos or something along those lines, that's the one that has all of these demos in there. So if you get home and you want to like go back through this, or we very well may not get to all of these today, although we're up against lunch, so I guess we could theoretically get to all of them, but I don't think we're going to try that. If you want to go play with them yourself or go see how they work or whatever, you can get the script and do it yourself and kind of play with it to your heart's content. The other thing is I'm doing all this in PSQL because some of the things that changed in 12 are kind of PSQL related, or it's easiest to sort of show those to you and talk about them. In theory, this is all just SQL commands and whatnot. So most of this stuff would work in anything, doesn't have to be PSQL. But I'm going to use PSQL for better or worse. Out of curiosity, how many of you do not use PSQL as like your day-to-day like Postgres tool? Okay, so it seems like most people do use PSQL at least fairly regularly. That's good. It's good for you. I'm not sure about everybody else, but it's good for you. All right, so we'll get into this a little bit more. Normally, I do actually like to start out my talks where I have everybody get up and give your neighbor a hug. I was told not to do that here today, so we're not going to do that. But hopefully, we'll keep it a little bit light and go through some of these things. I will start in order and just kind of work my way through the list. There is no real order to this other than like, oh yeah, that feature, and then I added it to the script. So for whatever that's worth, if we get to like, I don't know how long we're supposed to go, probably I would guess around 12, 15, 12, 20, and you are like, hey, what about this? Like we can kind of open it up. Like I said, there's a whole bunch of different functions and stuff in there. So we can jump around if we need to, because again, it's free-form open stuff. So JSONPath, really? We're going to start with that? I'm going to skip that one. Going to go to reindex concurrently. And it's very high-tech how this works. But this is good to know if you want to download the script and use it. Oh, I'm sorry, let me go back 1 second. Basically, there's a table of contents, and it kind of matches what each of the demos are. The one thing you'll need, so you need a Postgres 12 if you want to play with this yourself. The other thing you'll need is there's this thing called the pgtreats sample database. I have it. It's on GitHub, GitHub/Exzilla pgtreats. It's kind of like a DVD rental store schema, one of those things, which is, I like to say, it's like Netflix but for snail mail or whatever. Like. Just in case you're not sure how that works. But it's actors in films and people rent them and whatnot. So it's that basic schema layout that you've probably seen something similar in a lot of demos. So not too wild, but it's good for showcasing some of the features that we have. All right, so let's jump down to reindex concurrently. First, I'm going to show you, just to show this is real. So I'm doing this on my MacBook. This is 12.1, which is not the most current version of Postgres. Should be 12.2 if you're, or maybe compiled from head if you're super hacker person. But this is just, this is actually compiled on my MacBook, 12.1 based on the Git tag, but it should be the same as any other 12 that you get. I don't think there's anything in here that wouldn't work. So we'll start with the first thing. And some of these, it's kind of interesting when you do demos of features that don't have anything to really show. In this example, so it's the reindex command. There's a few things to kind of see here, but for those that don't know in PSQL, right, you do \h and then reindex, and it shows you the command. And the thing, like this is the whole feature, and there's a lot of code that goes into something like this, is the concurrently phrase. Now, you can put that into your reindex commands, and like all kinds of magic happens. And you would say, what kind of magic? And I'll show you the real command, I'll execute it. But the magic that is basically going on, if you've ever done reindexing, which I feel like probably most people have, even though maybe you don't think that you should. So you end up with this problem, right? You've got your tables and you're doing your vacuums and you're doing very awesome maintenance work, but for some reason your indexes still get bloated with like dead rows and that kind of thing. And you can re-index them, but that takes kind of a heavyweight lock, which can block inserts and updates. So that's a problem for most people. The trick that most of us use at the moment is something like we go create a new index with the same sort of set of fields or definition of the existing index. Once that's complete, then we go and we drop the old one. And that's a good workaround, has served me well for many years. But then sometimes you're on those systems where building that index takes like 3 or 4 hours and nobody's got time for that. So this now sort of eliminates that by adding the concurrently. It's like other concurrently commands. Basically Postgres is going to start doing the index build, going to kind of queue up transparently to everybody the changes that are going on, and then sort of resolve that for itself. And then when it can, it makes the swap, and everybody's happy. So I'll do an actual reindex. And the problem with showing this demo is like it really isn't all that obvious unless you have, like 50 clients going, and then it's a very big table or whatever. I'm going to do this. It's going to be super fast because it's on my laptop and there's nothing really going on. Oh my God, look at that. It's amazing. So it looks just like a normal reindex if you've run them, right? It's not really all that different. You can see some differences just because it may take longer than a normal reindex would, right? It does have to figure out the locking stuff on the back end itself. And so if you're on a very active system, it's not that it has some magical ability to avoid those locks. It just has the ability to navigate those for you, right? So if you used to build a new index and then drop the old one, in most of those cases, the new index doesn't care about any locking stuff because nobody's using it yet. And then once it's created, the old index doesn't care about locking because all the queries switch over to the new index, right? So this could take longer. It wouldn't necessarily take longer to build it. It's just a matter of once it's ready, it's got to navigate the locks for you before it can complete. So that's basically that. This is actually maybe my favorite feature of this release, which I know, like I said, it's not super flashy, it doesn't seem like, but again, 3-4 hour index builds is a part of my life that I don't really, I'm very happy to be giving that up as soon as I can get everybody on 12. So this won't convince your boss probably to move to Postgres 12, but this should convince you that like any upgrade you had planned, go to 12 instead. If you've ever done a reindex, you want to be on 12. So, all right. How about this one? It's a little bit of a weird one. Some of these are kind of niche. Some of these are not niche at all. So a lot of changes that go into Postgres, right? It's kind of all over the map. If you look at what I'm highlighting here, this to-date 10.3, now the thing that is fixed is that if you look at how the YY/, there's a space between the slash and the MM, and then another one between the space and the DD. I actually probably have an 11 I could pull up and show you. Basically, if you were to send that to Postgres 11, it would mangle that and give you like 18 BC or something like that. Like it doesn't understand how to parse that because those extra spaces throw off the to-date function, right? So it's kind of a little thing where you're like, I don't think this should really be an issue. But the problem was that in those old versions, it doesn't throw an error, right? It attempts to parse that, and it comes up with a format that is not what you actually want. So it will probably put the data in, but it will be the wrong date. It won't be what you actually thought it was going to be. And so that's one of the reasons like, okay, let's make this just a little bit more user-friendly so that you still have to have the basics there. Like you could still screw this up, I'm sure. But if you have at least kind of the basics there, like we'll accept it and we'll take it and make the right thing. Let me just pop that in there. And you can see like, oh wow, look, it gave me October 3rd back, just like you expect. Go run that in like some older version that you have like in prod, and then go look in your source code to see if you're using the to-date function, and then be terrified that maybe you have years of bad data that you didn't know about. Hopefully not. All right, another thing, with OIDs removed. How many people have ever dealt with OIDs? Not too many, that's good, a few in the back. So with OIDs removed, there we go. I'm gonna make a new table called with OIDs. So OIDs were kind of this secret thing. I don't know, secret maybe isn't quite the right word, but so they were like these secret columns that were used in Postgres, and they used to be used a lot if you go way back in the day to like the 7x versions. I forget, I think it was in the 8, we kind of got rid of them for individual rows. I think that was 7.4 actually. So it used to be every row in Postgres had its own OID. So there was like this secret object identifier for every row that like most people didn't really know about. And that was a really horrible idea. Because if you've ever heard of that concept of vacuum wraparound, right, maybe you've all have dealt with that, and that idea that like, oh, you can do 2 billion transactions, that used to all be tied back into this OID thing. So you couldn't have more than, roughly 2 billion rows in your table, not just transaction, but rows at all. So we got rid of that on the row level back in 7.4, so that's whatever, 15 years ago or something. But we still had some of the vestiges of this OID thing lying around, and it was a little bit weird to have that. So you could still create a table that had those row level OIDs in it. And it had been deprecated for like, I don't know, like I'm saying, it was 10, 15 years ago at least that was a thing. But if you were to look in a version of like 11, you could still create tables with OIDs in them. But we all know that's a bad idea, and we've told people for years, don't do that, and it's not going to happen unless you do it. So finally they removed it. So if I do this now, the odd part is, this is, again, not exactly the most interesting feature to look at. This will throw an error, whereas it wouldn't otherwise. Right? Syntax error near OIDs, which is what it should do, because that keyword doesn't work anymore. The thing to sort of see, if you want to see as a person, so we didn't quite get rid of them entirely. This is PG class, right? So this is kind of the main system table that has like all the table information and whatnot. And what you can see in here is that first column is OID. Now that column is actually in every PG class table in every database, going back to, I don't know, as long as anyone should ever go back, and then longer by a few releases. So that column is there, and if you do like select OID from PG class in like a 11 or 10 or whatever, you'll get rows back because it's there. It's just hidden from normal view. And so in 12, what we sort of basically decided was like, well, let's expose that. If we're going to have it, let's expose it where it is so it's not this special case, right? And remove that kind of from the back-end code. So you'll see that column, for some people you might say like, oh, that column got added in 12. Well, no, it didn't get added. It's just not a special case anymore, right? We treat it like a normal column, or at least a sort of normal thing. Again, I'll pull up some rows here, and you can see. Oop. Right, that OID in there. And it's basically, let me do this one. It's basically just an identifier for each of those things. And it doesn't affect much in the way of, your daily operations. Is it? Rel file node, okay, yeah. Okay. Yeah. So I just wanted to show this little piece of it. So rel file node, if you've ever had to try to figure out like what's the files on disk that are related to the table that I'm in, there's a thing called rel file node which actually maps to that. And so there's, again, sort of historical reasons that the logic of the OID actually mapped to that. Before we had a rel file node, the OID signified what that was. Yes, sir?
It only maps to initial.
Yeah, I'm getting there. So it used to be that the OID was what it was, and then we added a rel file node which maps to it, and then now if you do things like vacuum full or something that's going to rewrite the table, right, like that'll get updated and changed, so they may not match. So that's, it's sort of a historical thing, but it's still used in certain places that like we need to know what the object identifier is, and what's on disk doesn't actually work, so that's still there. We'll see how long it lasts or if that causes issues for people or whatever, but so that's another change. That OID option is removed. I really hope, I will be, like if you are actually still using OIDs and you're doing create table with OIDs on your existing systems, like I would love to have a conversation about that. Like I'm sad for you and you're gonna be in a world of hurt probably when it comes to upgrading. But I would be fascinated by that, just the disaster aspect of it. It's true. Of course, we also add new system views in every release. Pull up some of those. So these are a couple ones. These are kind of useful, and this is building on some work that we've had in the past. How many of you are aware there's I think it was 11, was added pgstat progress vacuum? There you go. Yeah, so pgstat progress vacuum is when you're doing long-running vacuums and you're trying to figure out, like, is this thing actually working or not? So you can look at these views and they'll tell you, like, oh yes, the vacuum, like not only like is it working, but like here's what's going on with that vacuum, like which portion of the vacuum process is it in. And so we've added a few more. So this one, probably pretty obvious, but this is for stat progress cluster. And it's, most of this stuff is pretty straightforward. If you're used to the stat views and you've looked at those, you have like your process ID, right? That's kind of the first column is the process ID. The database you're in, what's the name of it? The rel ID, which maps to that OID and PG class, so that's the, right, you can join to that to get the table information. The actual command that's being run, which phase of cluster it's in, right? Because there's different parts and depends on the table. So it has to like scan the table, it has to look at the indexes, rewrite all those pieces. So there's different phases of that. And you can, those details are kind of all in the docs. You can check that out. And get some statistics about what's going on. What's a little more useful is if you put some machinery behind that to periodically get this information out of Postgres. Because in this case, this view in particular, like it only lasts really while the commands are going on, right? So you can see the current status, but if you want a historical thing, you'd have to capture that data and keep it someplace else. So, and then there's a similar one for create index. This is probably more likely to be used and be useful, but kind of works the same way, right? So still process ID, what's the command, what's the index relation and the table relation that it's involved with, and all those kinds of things. So, and if we look at it now, there'll be nothing in there. So like I said, there's one for vacuum as well. That was in a previous release. Yay. I'm not creating any indexes. All right. We'll just go down the list like this. Foreign keys are now named with all columns. So one of the interesting things, sometimes when you're doing these upgrades, depending on the method of upgrade you're doing, if you're doing like PG dump and restore and that type of thing, this probably doesn't matter to anybody, but potentially your foreign key names will change. So if you're doing something based on how it was named, this will now be different for you. I'll do you the real world example here. So let me show you the table first. So there's a table in this database called film actor. Hey, it's actually there. It's just like an actor ID, film ID, and then the last update column, right? And then those are foreign keys off to another table, or other tables. So I'll make a new table called foreign key naming, and a couple of ints, and I'm gonna do a multi-column foreign key, just so you can kind of see this. This makes the most difference the longer your potential foreign key names are. So if you have very long column names or you're doing lots of columns, it makes it take longer. And so now, it used to be that we didn't really include all the different column names in there, and we make, I'll say more of an effort. It's still possible to make something that is so long that Postgres won't actually deal with that, and it'll just kind of truncate it and then put that in there. But you can see, right, foreign key naming AF F key, which is probably what you would normally expect. I think in 11 you would have probably gotten foreign key naming underscore A underscore F key. So, because it would not really pay attention to that second column. And so that's, again, it's a little subtle thing, and most people probably wouldn't even notice that, right? If you do like a PG upgrade or whatever, it'll pretty much only happen on new ones. The reason why I say you might notice it in PG dump is like you basically have a logical SQL script. So what it's gonna export is basically an alter command that adds the foreign key back in. Actually, it might preserve the name in there, now that I think about it. It probably should preserve the name even in PG dump, because it's already got a name. So maybe you wouldn't see a difference there. But just be aware that if you are relying on that naming scheme for some reason in your code, and that seems odd, but I've seen a lot of odd things, so that will be different now. You'd have to change for that. Anybody here speak a second language? The power of the American education system. I'll let you decide what that means. So we added a bunch more languages. I believe there were 8, maybe 12 at the most in previous releases. And these are basically, if you're trying to do full text searching, some of the language libraries are more built in than others. We added a bunch more into the Postgres 12 release. So if you're a big Irish speaker, yeah, not to be confused with Gaelic, I guess. Whatever. So if you need one of these other languages, it's there. Like probably you've already gone through the trouble of getting it in there, but if this was a blocker for you, this will now be easier. There are still more languages out there, obviously, and libraries out there that you can load externally, but this makes some of the more common ones at least a little bit easier. So I think most of us speak simple, just FYI. So I believe that simple, this may not be true. So most of what I'm going to tell you today is true. This might not be. I believe they called it simple because originally in the Postgres project, English was reserved for people from the UK. And when the Americans tried to get involved, they were like, you can't use the same dictionary as us, so we're going to call yours simple. And they sounded smart when they said it, so we were like, okay, that's fine. Can't guarantee the accuracy of that story, but I think it is true. All right, create or replace aggregate. Again, this is one of the super simple things. If this is the thing you had to do, your life, just got a little bit easier. All you're really seeing is there is now an or replace thing in here, right? And I know that doesn't seem like a big thing, but again, it's like most of you probably don't remember when we used to have to like drop functions and then create them again, because now we have create or replace function, right? And that makes your life way easier in just a really tiny way. For aggregates, it's been that way all until Postgres 12, that like if you needed to change the definition of your aggregate, you had to drop the existing one and then create a new one. And again, that doesn't necessarily sound bad, but there are cases where you'll have dependencies on that, and so then that breaks the dependency tree and you have to figure out how to manage that, so that's kind of a pain. This makes it a little bit easier to do that, so yay for making life easier. Also, I have a note to mention this. You may have seen this. So create aggregate is, as you can see, there's a lot of options here in the create aggregates, or there's the old syntax, which is this one. So a lot of these commands have a lot of different things to it. If you ever look at like select is a similar thing. PSQL now does this handy piece, which is it is added in URLs to where the command is in the documentation. So if what you see here, which if you're looking at this, you're like, oh, this command has 20 or 30 options to it. And I don't remember what, I remember most of these. God, that's not good for me. I don't know, min, final, func, modify, shareable. I don't know what that means. So I now could get the link very easily and go pop that into a browser and then look at the documentation on it. I'll give a little bit of a warning that PSQL is mostly backwards compatible, right? So that like you could use it against an old version. And as far as like dealing with system views and whatnot, it should work. I mean, I guess I'll say it should work in 100% of cases. If it doesn't, report that as a bug. But some of the things in there, like these URLs, they only point to the 12 docs. So if you're working on an older version with the version 12 of PSQL, be aware you're not going to go to the right version of the docs. So you do a little URL hacking, and you'll get to the right version for most of the commands. It should be there. So just kind of be aware of that. But if you need more information, it's much easier to actually find it now because we give you the URL. Reindexing curly I already did. Oh, let's talk chained commits. There might be a real name for this feature, and it might be chained commits, but that's what I'm calling it at the moment. So chain commits is how I describe it. You can now add this extra syntax for and chain clause into a transaction command, right? And it preserves transaction settings across commit boundaries or rollback boundaries. And you can also make use of that in stored procedures, right? And so that's kind of a little bit hard to parse, which is why we do demos. So let me do you one, and you'll see how this works. So we're going to start with, I'm going to show transaction isolation. By default, Postgres is a read committed database. That's how it normally works. That's obviously the best solution for everybody, except when it isn't. So that's why we have it as the default. But some people use things like serializable. So I'm going to make a serializable transaction. And in case you don't believe that I'm doing this, I will show you. And so I'm now in a transaction, and this transaction would work as a serializable transaction, which, without getting like super into the weeds on transactions, basically means if you try to run concurrent transactions on the same piece of data, they'll be serialized, right? They'll kind of back up against one another, right? And so the more you have, they'll just kind of queue up-ish. It's a really loose explanation of that. But the important thing is that because you get different transaction semantics, you can get different behavior out of Postgres. And so for that to go away can be a problem if you're expecting to use that. And the people who kind of use that usually have a good reason, and when they do it, like, it really matters that it preserves the right transaction semantics, because otherwise you'll get things kind of out of order. Normally Postgres is cheating, don't tell anyone, and it's, you know, you can maybe see some things that you shouldn't be able to see if you look just the right way, but with serializable transactions you cannot, like, it's very kind of gated. So let me throw some data in here. I'm going to insert some first. So that inserted, I'm still in my transaction, so that's not committed yet. But then I'm going to use this is the magic new stuff, commit and chain. And that transaction is sort of more or less committed, but because I used the and chain, it's preserved the transaction semantics that I had before. So I will now insert another row. And that went in okay. And then I'm going to roll back in chain. Now, before I do this, I want you to start thinking about, I inserted the first row, the Dylan row, and I committed that. So maybe you think it's in the database. I'm now inserting a Robert row and said it was in there, but I'm going to roll that back, so you probably think that's not in the database. And then I'm going to add a third row, which is the Emma row, and I haven't done anything with that. Maybe that's going to be there. I'm going to commit and chain that one. So you probably think that one's in the database. Anybody think that that first row, the Dylan row, is not in the database? Notice that I've done a rollback at this point. Okay. Yeah, okay. Just seeing, just trying to see if you're all there. All right, commit and chain that one. Now, even though I've done these commits, normally if you were to do this, you would be back into the old, you know, regular sort of repeatable read type transactions. But here, I'm going to show you the transaction isolation level. I'm still in that transaction isolation level. We've still preserved that context, right? So, and there's other things you can put in there, but that's kind of the most obvious one. And I will now, let's go look to see if the Robert row is actually there. So this is the one that we rolled back, right? Who thinks it's going to show up? Anybody? All right. Not really trying to trick anybody. So we have the Dylan row and the Emma row. We've rolled back in the middle, and even though we did that rollback, we were still able to serialize all this data entry because we've been able to chain the transaction semantics. Now I need to actually commit this one last time to make sure everything is really in there. So I'll do a commit. And after this commit, right, I didn't chain anything, so we are now back to our old transaction isolation level, I hope. Hey, look at that, recommitted. So we went back. So there's some other things you can plug into that, not just transaction isolation level. That's probably the most common one. But if you're looking at trying to figure out, like, okay, I need to do conditional logic, but I need to make sure that I'm preserving the state of the transaction and that everything goes in the same way, commit and chain is your go-to. So I'm kind of excited to see where that goes. Honestly, like, that was one that kind of slipped like under my radar during the 12 development cycle, and I kind of found it after the fact. And I was like, oh, this seems pretty interesting, and I haven't heard too many people talk about it. So we'll see how people start to make use of that as more people get aware that that's a thing. So why are you, don't beach ball on me now. All right. Let's look at statistics. This is another one that I think if you really need it, you definitely really need it. Creating statistics for multiple columns. One of the problems that Postgres has in general, right, so it uses statistics on different columns to figure out how do I do my queries and make them work correctly. But where it starts to break down is when you do things like aggregates or you're doing like multiple column joins and that kind of thing, it has issues around that because it doesn't really understand the relationship between two different columns. Right, like it understands like maybe this one everything is unique and this one there's 10 values across 100,000 rows. So when I, query on the combination of those, what should I actually expect? And we can figure this out because like math and stuff. But Postgres doesn't do that on the fly. Doesn't realize maybe that it should or whatever. So we now have a way to actually explain that. And I give sort of this example because it's already in the database, so it works. So if you look over here, I'm querying from my city table, right? And I have a bunch of cities in the database. And the thing I want to point out is in our database in particular, and it turns out there's a lot of cities like this, but we have two different Londons, right, in the city table. One of those is in the country of 102. That's the UK. I guess they still call it the UK, right? That country, yeah, it's got issues. And then the other one is in country ID 20, which is the United States, which has different issues, but we don't rename our cities or borders, apparently. So depending on which of these you are actually looking at, right, like most cities are actually going to be unique, because a lot of cities have pretty unique names and they don't exist in more than one place. But we do know there's definitely, especially when it comes to towns and cities in the UK, they happen to have those same names scattered all over the globe. Just, I think it's coincidence, I guess, that all of these cities are named after cities in the UK. So a lot of those, right, like if you are dealing with that kind of a city, maybe there are multiple ones. And so then the statistical relationship of a normal city might actually be different than one of these other cities, right? And that's the kind of thing that, like, Postgres doesn't really know that it should do something about that or should think about that. Like, because to Postgres, these are all just numbers, right? And so it doesn't really understand that there's a relationship there. And what we now can do is we have this create statistics, and you can do a geopoint, and so I don't have to remember it. Let's see if anyone in the crowd wants to pipe up with what MCV stands for. I knew Stephen would. Most common value, there you go. There's actually different statistical things you can put in there, and I think it's quasi-pluggable, so you can build your own if you want to. But what I'm basically doing is saying, I'm going to create a statistics point on these two columns, right, on this table, and say these are related. So go generate statistics on the data in these two columns and store those with the other statistics about the table, right? And then once I have that in place, if I go to query on that table and I make use of those, whether it's, you know, kind of whatever the query is, you probably need something a little more complicated. But if I were to query on that, it can now make use of that if it needs to, right? And I've now explained that relationship that, like, hey, these are kind of, the first place I look for these is things like cities and countries, or like zip codes and states and that. If you're doing work in like geospatial work, I suspect this is probably going to be pretty useful for you. You may want to go and look and see where have I had problems, where I've had to deal with a problem like this, and maybe done something I shouldn't have with the planner. Not hints, of course, but something. But anyways, you can now try to create those statistics points. And again, it'll work on any columns in the database that you want. If you have relational data within a table, you can create those points. And then it's just, you know, just like with analyze, whenever you analyze the table, it will update those points. So as your data changes over time. So that, it's one, again, like there's a certain class of people, like this is the thing that probably was blocking them from using Postgres, and now we at least have an option. Generated columns. This is another interesting one. So generated columns is a new feature. It's in some other databases. Works pretty similarly. And this is really, I think, the first version of it that we're going to see. And there'll be some features that will fall out of this. The basic idea is you can now create things on your table called generated columns. They have to be based on computed values. And they can't use SQL queries or reference like other generated columns. And I'll show you the example here to kind of build one out. There are ways around that if you want to kind of break Postgres or the planner. And I'm not going to show you those here today, but I know they're out there. But let me show you the basic thing so you can get an idea of how this should work. So I have this table film. Let me show you the table before I do this. Right, there's a bunch of data in here, and this is basically like, think of a movie, right? It has a title, a description, the year it came out, all these different things. The rental duration, the rental rate, right? Replacement cost, if you lose the movie, like we're going to charge you for that, all that kind of stuff. So there's a bunch of data in there. And what I want to do is, like you said, alter the table film, right? I'm going to add this column called revenue potential. And I'm basing this, it's going to be money, so I'm going to use numeric 5.2. Don't ever use the money type. Anybody using money type? Okay, good. Don't ever use that. So numeric 5.2, I'm going to generate that. So instead of me having to enter the data itself, I generate it always as rental duration times the rental rate. right? Because the potential revenue I should be able to get from one of these movies is, well, what does it cost to rent it, and how long can they rent it for, right? It's my theoretical business definition. So that's going to generate that data. And then I have this keyword in here, stored, and essentially now basically everything works as stored in the first pass. But there's some different ways that we'll be able to do this so that it can be generated on the fly instead of stored, which will come in later releases. But for the first version, pretty much you'll be doing stored stuff. And so now if I look at the table, right, you'll see I didn't add the data, but the data is actually there. Right? And if you do the math, what's an easy one? Maybe like 3 times 499, seems like it would be about 1497. It is generated this for me. Right? I didn't have to do anything to get that in there. And if I put a new row in, if you look at this, I'm going to put in the title, the language, the duration, the rate, and the revenue potential. And here's my movie. It's a new one that came out. It's really good, I heard. I didn't hear that. I really did. I wish I had heard it. So the duration, right, here's my rate. Now I can put in a value for my revenue potential, right, which I'm going to do that. Oh, good Lord. No, I can't do that. I was just kidding. Right, so I tried to insert it into, and then I had the column revenue potential, and then I just lied to you all and said I can do it. And I can't because it's a generated column. So Postgres knows, like, hey, you're not supposed to put data in here. It's a generated column, right? This isn't like a default value on a column. This is a generated column. So that's part of the power, right? Like that's actually part of the feature, is that you have certain columns and potentially you really only ever want those generated. Nobody should be in there, you know, overriding that data or mucking about with it or whatever. And so, right, like if you try to insert in there, it will throw you an error. Postgres has your back, I suppose. All right, well, let's look at this, though. Pull out number 1. And that's hard to read, so let's try this version. Well, everybody knows about \x in PSQL? Oh. So normally when you do commands, it kind of writes it in a row horizontally. If you do \x, it changes the axes of the data, so you get it in this vertical way. And you can actually do \x auto, if I recall, and it will attempt to do the right thing every time. And so you'll be frustrated 25% of the time. But it is definitely easier to see. Certainly, usually when you have like long text and that kind of stuff, it's easier to look at it like this because everything is on its own row. Right? I have my revenue potential of 594. I'm going to change my rental duration to 5. It is currently 6. Right there is the 6. And everyone expects that it is now updated, right? Hey, look at that. So it changed to 495 from 594, just like you thought it would. So it'll help keep that information up to date, right, even as people are updating the column. If you want to see the sort of guts of that, we're going to look in the PG attribute table. That's a system table within Postgres that basically stores information about all the columns in your tables. And we're going to go back to the other way. Nope, that wasn't really any better. Actually, it was better. So basically what you need to see, so these are all the columns in the table, right? So my @rel ID is film, right? I'm looking at the film table. So here you see there's these secret, hidden, seated, xmins, all that. Then the actual columns from the table, film ID, title, description. At the very bottom, there is this revenue potential, and @generated is the thing that marks whether it's a generated column or not, is the column. And so it has an S in there for stored, right? So we've got some machinery that's put in place to be able to do these like generate on the fly in the future, and you'll see different values in there once those features actually get released. You can also see this in a more, do we say human readable? That feels kind of weird. More personable, outgoing, friendly way. Which is, you can look at information schema, a more SQL standard way, that's probably what I should say. So there's a more SQL standard way to do that, which is to look in the information schema, column usage. On the film table, there's this dependency in revenue potential, it is dependent on these other two columns, right? Rental duration and rental rate. So if you ever want to go look at the dependency tree for your generated columns, what is it looking at? You can see those dependencies in the information schema. So just be aware of that as well. And that's generated columns. So that, again, I think that'll be pretty nice to do some stuff with. All right, new per table vacuum options. Just what we all like to talk about. How many people here love vacuuming? Yeah. You're such liars. I meant in Postgres. So, there is no Roomba for Postgres. Not yet. We're working on it. I guess there's an auto vacuum. It works as good. All right. I have a rental table. Stores my rental data, right? People that have bought stuff. I'm going to change some vacuum options on here. So two of these options I'm changing are vacuum index cleanup and vacuum truncate. Vacuum index cleanup, what that controls is normally when you vacuum a table, right? First it scans the table data itself and cleans that up, so to speak. And then it goes and it vacuums all of the indexes. And it's all within one command. It's all within the same vacuum command. But it does it in different phases, right? And if you look in that vacuum stat progress table, you'll see the different phases. So you can actually turn that off. If you're a big fan of re-indexing, which maybe you aren't now, but maybe you will be because you're in Postgres 12, you can do it concurrently. It's awesome. You may decide, when I vacuum tables, I don't actually need to ever vacuum the indexes because I have a regular maintenance plan where I'm re-indexing those anyways, right? So I'm going to handle my bloat that way. So you can set this up on a per table basis, right? Like for this table, don't do that anymore, and for other ones, maybe you want to turn that on or off and do what you want. Vacuum truncate, what that controls is at the at the end of a vacuum, if it finds pages towards the end of the file that are not needed, then it reclaims that space even on like the lazy vacuum version, right? Without doing vacuum full. You don't have to do that. If you know your vacuum is gonna, or if you know your data is just gonna take that space again, there's not really a huge need to reclaim that space, so maybe you don't want to, and you can turn that off. All right, and I've set that, and you can see these things. Do the \d plus. I heard clapping. Let me know if that means I should be stopping. So \d plus, down here at the very bottom, we have this options, index cleanup off, vacuum truncate off. Right. And if I vacuum this table, you'll see, right, I have some indexes on here, 2 or 3. Normally you would see something happen there, exciting. 15 more minutes? Okay. Q&A, all right. So you can see it does a vacuum. It kind of looks the same, but it didn't touch any of the indexes like it otherwise would have, right? And in fact, I can manually turn that back on if I want to. And now you see, right, I turned the indexing back on with this index cleanup on flag, and like suddenly, hey, look at that, all the indexes show up again, right? So even if you turn it off by default, if you find you really need it, you can turn it back on. So I don't have 15 more minutes. All right. Well, let me go back up to the very top. And let's see, blah, 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 chain commits, generate column. Common materialized expression. Oh, that one's really good. Explain settings is really good. There's a lot really good. Okay, who wants common materialized expressions, explain settings ons, or PSQL tricks? All right, that's what I heard. So I guess that we get that one. Well played. All right, PSQL tricks. First, a new command, con info. Basically, I know it doesn't seem like it's magical, but it is. This tells you what you're actually connected to, who you're connected to, what the socket is, and what the port is. And you would think that that's not like crazily awesome information, but actually if you're in PSQL, there's no real way to get that info. So now you can get that. pset format CSV. Oh yeah, this one's kind of nice. I think it'll error too. So pset changes how PSQL does its formatting. I've changed the output format to CSV. You will see what that looks like here in a second. Right? So when I now select stuff out of the table, it looks like a CSV. The normal version of that is aligned. So I'm now back to aligned, and hopefully it will look like it should. Look at that. So now it looks normal. So you can now change that, and if you do something like /o with a file name, you can put that out to a file and it'll be CSV'd. There's other ways to do that. So there's some PSQL tricks. Let's do this one real quick. Labeling partition tables. I have a partition table in here. So you see down at the very bottom, we now include some of this information. Number of partitions 6, there are 6 partitions on the table, you can see that. So that could be it, or I can keep going and people can just start walking out. I'll work my way back up and then somebody will leave and turn the lights on and then we'll know we really have to stop. df-pg-promote is a function now available in Postgres 12 to promote your standby from the SQL callable level. So normally, if you remember, like you probably had to touch a file on your system and to promote it. We now have a function that actually does that in the database. So you can kind of automate that at the user level. And you can tell it to wait a certain number of seconds before it does it or whatever. So that's a new function available. Oh, this one I wanted, yeah, this one, I like this one. Copy with a where clause. We'll see if this actually errors, it might. So I'm going to take this table customer list, which is actually a view, I believe. Yep, that's a view. I'm going to copy the data out. So let's say you had to do like a data export. Somebody needs some of your data. 600 rows. And then I'm just going to show you a little bit of the data. Everybody knows \! Right? That allows you to run basically escape out to a shell and run a command. So I'm running the head command on my local system against the file I just made. And you can see, like I've got a bunch of data in there, right, that I've just exported out as a CSV. If I wanted to, if I needed to be able to create a table with just a portion of that data, I make a table first. I do a limit 0, another sort of little trick. If you do limit 0, it'll copy the structure of the table without actually pulling into the data. So I now have a place to put this new data. And then the magic part is this copy command. So I'm doing US customers from my CSV file with CSV. I can now add this where clause to the end. And it will actually, as it's interpreting the data and pulling it into the table, it will apply the where clause to that copy command and only pull those rows. Right, so let me pull this. Blam. So you can see I copied 36 rows. So there were 36 rows that were in the original file that was 599, and Postgres just handled it on the fly. So certainly, like, there's a lot of ETL jobs I know I've written in my life where, like, you're loading up the file and then you're selecting back out the data that you need. You can now do that on the fly, adding the where clause to the copy command. So that's a really nice little feature to speed those ETL processes up. I need 3 more people to leave or I'm not going to stop, so just letting you know. Log transaction sample. Oh yeah, that's good too. Oh, look at that. You're waiting for me to say, like, this is the bad feature that I don't like. It's not going to happen. Well, it might. Log transaction sample rate. So one of the problems you have on very large systems, right, you have a lot of query activity. You'd like to log all the stuff, but you can't because there's so much going on that it kind of overwhelms your system. We now have a way to actually log a sample of that information. And there's more work on this in 13 that's coming as well, but it basically logs all statements from a fraction of the transactions, right? So if you can only do 10% of the ones, like, you'll get a sample of all those transactions. So that's definitely really nice, you know, to get a kind of a better real world of what's going on. I think what a lot of people used to do is you'd set like log min duration, you know, to like 1 minute or something, right? 30 seconds, and try to get the more expensive stuff, but you're missing out on like all these other queries that might be changing and that might be a problem, but you don't see them because they're so fast you can't get that. If you use this method instead, right, you'll get a sampling of those queries, so they'll show up as a better representation of what's really going on in your data. So Postgres 13 should have the ability to combine those 2 features, so duration and sampling. So I'm hoping that'll be good. You may have heard all this hype about pluggable table engines in Postgres. Anybody heard about that? I don't see hands. Oh good, I'll just skip the feature. Cool. It's all hype, so you don't need to know about it. That's the story. You can now add entries to enum types on the fly. That was the feature I didn't really care about. So there you go, you got it. That was the one. Find any relation interesting. I know that exists. I think it's not a, it's the other feature I must not like because the demo doesn't work. All right, we're gonna skip that one. Woo. Oh, this one, there's a lot going on in this one. All right, we'll do this one quick. Create table, rental report. I'm gonna make a report with some JSONB data. All right, and then I'm using my tried and true MongoDB schema tool. So here we go. So report is the column. It's a JSONB. That's where it's all going to go. And I'm going to throw all this data in there. Right. So there's a bunch of JSONB data about customers, the day they rented a thing, and then the title of what they've rented. Right. Let me throw all that data in there. Blam. 7 rows. What I now have the ability to do, this is the new part. So this report points at customer as customer from rental report. I now have the ability, and this is, so all of this is under this concept called, let's get this right, JSONPath, thank you. So this is all under the space of JSONPath, right, which is a whole new set of features, lots of functions and whatnot. And I think it's a SQL standard feature. Postgres really has the most complete implementation of this out of any database, at least that I have seen, and I've seen most of them. So it's really going to be interesting to see what people build with this. But normally I could do something like this where I'm just going to pull the customer information out from my rental report, right? So I pulled that out of the JSONB record. But maybe I need to do something a little fancier than that. So here I'm going to use JSONB path query. I'm going to go look at the report column, right? And I'm using some sort of JSON-oriented syntax, if you will, to pull out a wildcard with the customer information from the rental report table. And in theory, actually I'm going to do the last one again. So, and if I do it with the JSON path, this is basically to get the same data, right? But using the JSON path. This is the normal way you would do this in Postgres now. This is the JSON path version of that. But I can also do things like this, where I grab the title of the movie, which in this case it isn't super obvious. In my rentals JSONB, this is actually nested JSON data, right? This is not top level. So customer is top level data in here, right? This is a top level field, rental data is, but rentals is not. Inside of the rentals, right, it's a JSON object. I have other information in there, one of which is going to be the title, one is the rating of the movie. So I can grab that, and like suddenly now I get the titles, right? That's person number 2, I think. I wasn't counting that well, but one, oh no, he's going to be the third one. So if you're mad, it's this guy's fault right here. What's your name, sir? Everyone is going to hug you and give you a handshake, and it's not because we're being nice. Oh, now that he's going, you're like, I guess I can leave now. Yeah, I didn't want to be the one. So I just want to show you, so you can now pull out like more information and do it right by ordinal as well. So here I'm pulling out both the title and the rating, right? So, and this, I mean, this is really scratching the surface. You could easily do a 40-minute talk on JSONPath. There's so much in there to uncover. I haven't actually found anyone who's done that talk yet. So if I do, like, I'll definitely tweet it out, I guess, or something, so that people can find out about it, because that is going to change the way people write applications. Yeah, maybe submit it for, if anyone wants to do a talk next year here, like, do something on JSONPath, and you'll definitely get accepted without a doubt. So, all right, that's it for me. Thank you, everybody, for coming.